When I talk about desemiotization, it's of course because originally we thought of the world or nature as a semiotized system, if you like, a system full of messages, of signs, of things which were told to us. In the Christian period, and I'm afraid just very shortly we'll have to go very long back, because what went wrong right from the beginning of modern science, and we'll have to find it, grasp it from going back in time. Who coined this metaphor, the great book of nature? We had two great books, the great book of God, which was the Bible, and then we had the great book of nature, and they should be read together, so to say. And what he says here, God, whom you want to discover, never wear that book with ink. Instead, he set before your eyes the thing that he made. So can you ask for a louder voice than that? So originally we had this semiotized up the conception of nature. But it started perhaps already to go wrong in the scholastic period, because for some reason the scholastics only learned half of the Aristotle on whom they based a lot of their thinking. And that was the half in which he talked about human signs or symbols. And then the other half was sort of forgotten all the natural signs, fever or animal tracks, things like this. The whole semiotics of nature was forgotten there. And for that reason, of course, the nominalists, and particularly William of Ockham, of course, saw that the consequence of this understanding was that our knowledge of natural phenomena was entangled in the web of human language, and it has never come free of that ever since. The sign became humanized. Yes, it became simple. There was nothing but symbols. Nature even is a symbol in the language, isn't it? As a consequence, nature became dehumanized or desemiotized. So here is what I'm going to say, if I can reach. So we are starting first with the conception of bodily things. I think we should make clear to ourselves that causality is not just a psychological phenomenon like Hume supposed it was, or it's not just a transcendental category like Kant thought. It's actually something you experience when the toddler rises or crawls around on the floor and then rises under the table. She will hurt her head on the tabletop. And that's when it appears to her that something she herself did caused this. This is the root, of course, of causality. That's how we learn it. It's an experienced thing. And we learn it by living. And that's the only way we can learn about causality. And when we use force, of course, it again has something to do with bodily things. We need to sort of push or draw or whatever. So, in a way, these have their roots, these categories have their roots in life. So, how come that it works so well if we project these categories or these terms into nature at large? I think that the very fact that it works tells us something very important. It tells us that the dynamics of the world is very much the same as the dynamics of life. And that's a kind of abductive inference, of course. It's just something which should be hypothesized for very strong reasons. Now, this runs counter to the whole ontology of natural science for many, many years, because already in 1620, Francis Bacon, the English philosopher and a lot of other things, wrote in his famous book that human understanding is like an uneven mirror receiving rays from things and merging its own nature with the nature of things, which thus distorts and corrupts it. And ever since this, the taboo. There's been a taboo against final causation in science, and actually, it has been one of the worst errors you commit is to suppose nature contains final causes, and yet Darwin told us that humans were themselves products of nature, and from then on, it's a paradox. How can we be part of nature and final causation not exist? So somehow we have to solve this contradiction, and that's what I think Charles Peirce did, or showed us the way how to do. He said that it's a widespread error to think that a final cause is necessarily a purpose. A purpose is merely that form of final cause which is most familiar to experience. And there are a much broader category of final causes in nature, but we don't like them because if we mention them, people in the Cartesian tradition always think of purposes in the human sense of purposes. And the second law of thermodynamics, I won't go into explaining it, but we just heard, of course, is a kind of this final causality in the Persian sense that we just heard Terry explain from his wonderful book on how thermodynamic systems might become teleodynamic. So it seems legitimate now to talk about final causes of some sorts. There's a lot of problems with it, but we should be very careful. But I think it's legitimized. So, and semiotic causation, bringing about effects by interpretation, is a thing which goes on in nature, in living nature at all levels. Sign processes are inherently intentional, and biosemiotics, that's the thing I'm working with, that is semiotics of nature, or natural systems, implies that all living systems possess a kind of agency, or, if you like, intentionality. Understand me right. Therefore, agency has a natural history stretching from the first hesitant beginnings in bacteria to human consciousness. So that's about cognition and body feeding. I'm now trying to say a little bit about how or why we need sensory semiotics. And it starts, as always, here because Descartes was the first of those philosophers spreading the new message that he was actually a wonderful biologist also, and he, as you can see, he made all these studies of how the mechanical system of the sense apparatus was doing. But what he couldn't answer, of course, is how can sensory impressions become thoughts and ideas? I mean, this is the homunculus problem. I think Terry presented this problem yesterday, that it's one thing that we can see, but how can we know what we see? I remember my physics teacher at high school when we came to optics, telling us that the babies would see the world upside down, because as you can see on the right part of this, the refraction of light will mean that the projection on the retina of the image would be inverted. So, of course, this idea is strange because it would presuppose that some homunculus in the brain, that was a screen in the brain, and that the projection would go into the brain, and then some homunculus would sit there in the brain and look at this screen and telling me that, no, you're seeing a fried egg. And of course, the stupidity of that explanation is that then this homunculus, how can he know? So we can only know this because he has another, even smaller homunculus in his brain, sitting and looking at the screen inside his brain. Of course, this kind of explanation is stupid. So we can't do it that way. And so how can we do it? I think we must admit that it's very impossible. At least that was Descartes' own understanding, that we had res extensa, things which was extended in the world, and then we had a totally different realm of res cogitans, or thought substance. But then, of course, if they are so totally different, how could they work together? And this has remained, I think, the problem even today. How can you imagine res extensa and res cogitans working together? And you can't. And for that reason, the university things and scholars have been divided into the two realms ever since. You have the res extensa scholars studying natural science or medicine and calling themselves materialists. And on the other hand, you have res cogitan scholars studying humanities and phenomenology and sort of seeing themselves as idealists. So idealism and materialism it's simply instituted all over the world in the very way we divide the university and the faculties. And Kant, of course, because he was such a clever man, saw that there's no way we can go from one thing to the other. So that's the basis for his knowledge that we can never come to know das Ding an sich. I think we have to go back to the Cartesian sensory mechanics, the whole idea that you can mechanically sort of trace the origin of the mind, if you like. That's not possible. You have to substitute sensory mechanics with sensory semiotics. And that's what Charles Peirce saw more than 100 years ago. And nobody has really, or only very recently, taken any notice of this. And that's what I have worked on more or less for the last 20, 30 years. So here we come to what I would call semiotic realism. As I started saying, the world is knowable. We saw there's nothing a priori, as Kant has told us. There's nothing a priori about our understanding of causality. It's simply an experience. And there's no good reason to believe there's anything a priori about understanding of space and time. We experience it from our earliest steps in the world. Our understanding is rooted not in all these ideas, but in lifelong semiotic interaction with the world in space and time. And I'll quote Ty Cashman here in my own wordings, but it's more or less his message, that with our fingers, arms, legs, etc., and through the means of thought and imagination, we expose the things before us to our curiosity and volition. If a Kantian would claim that the pencil on the table in the front of me cannot in principle be known, I must answer that I do not just sense the pencil mechanically, for my knowing the pencil does not start in the retina and it does not end up in the brain. Rather, it flows back and forth through an indefinite number of loops where the pencil is integrated into the movements of my fingers and thus into a world of immediate and as well as memorized bodily experiences, and back again to neural circuits in the brain, forming a continuous and branched set of loops. My interaction with the pencil is historical and semiotic. It's not mechanical. And from the moment you see that, you don't need all this nominalism, if you like. So, what do I mean with this sensory semiotics? There's an enormous difference between believing that we think in concepts as the primary thing. Somehow the res extensa becomes res cogitans concepts, and believing that we think in science. Because concepts refer and science signify. The girl there sees the apple and knows probably it's an apple, but probably even before that, assuming she likes apples, she would say something like, And that's the that's the way of science. It's signifying. So that you could say, to sum it up shortly, we can know about the world because it inevitably assumes signification. We do not mysteriously possess an internal conceptual model or representation of the world. Instead, we are embedded in the world as meaningful. Only through our analytical skills can we collectively and scientifically learn to designify it. So I think it's the other way around. We start by signification and have academically to reach a designification. So it's the opposite of the Cartesian tradition. And that I call semiotic realism, because it's a realist position. So let me expand a little. I hope I have time for the next three things also. On the concept of scaffolding, which I think is a very useful concept in this context. Of course, scaffolding is what we use when we construct buildings. But I would like, in accordance, I think, with several other traditions in the humanities and psychology, to extend the concept of scaffolding a little bit and talk about instructional scaffolding. I think it was Jerome Bruner who first introduced this idea, that somehow the provision of you need to make sufficient support so that you can promote learning when concepts and skills are being first introduced to students, as like this child learning to swim by being supported by something. It could be, that's what we learn in school. We learn roads and things like this. My German teacher was a very wonderful teacher, and when we had to learn about all those difficult rules about which nouns would have umlaut in plural and which nouns would not, he in all those kind of grammatical questions, he always told us a story. And so we should, in chorus, the whole class would sit and say, "In der tiefen, tiefen Nacht." And then we would say, "Die Nacht, die Nächte." "Im schwarzen Wald, der Wald, die Wälder, gab es ein kleines Dorf, das Dorf, die Dörfer. Denn plötzlich kam eine Wurst, die Würste." I'll never forget that. This sausage is simply the cue of the whole story, of course. And it went on in this way. And that's what I mean by instructional scaffolding. It scaffolds us our ways to grasp things. So scaffolding is an important concept. Let's just spend a little minute on how it works in nature. I show you here the evolution of the hemoglobin molecules, and there's no reason to go into the details of this. I even can't remember all the details. But as you can see, around 800 million years ago, already there was a kind of globin, a protein molecule that was a little like the hemoglobin. But as animals increased in size, they could no longer depend on diffusion of oxygen from the outside to the inside. So they needed some kind of transporter, which then the hemoglobin molecule became attuned to that function. You should also know that oxygen is actually poison, and it's very poisonous to cells, so it has to be buried deeply in this hemoglobin molecule in a very secure way so that it can't spoil all the organic molecules inside the body and become delivered at the exact right position inside this cell. So, and we can then see it split into two kinds of, rather soon after that, this is the first, around the first bigger animals. Rather soon after that, there comes a split into a hemoglobin, which is myoglobin, so slightly different molecules used to transport or protect oxygen inside muscles, and not to transport it, just to keep it inside the cell. But what's interesting here really, as I see it, is that when we then have this split. I can't explain why there came this. Yeah, we call it 4 alphas and 2 alphas and 2 betas. But the interesting thing is that when mammals came about 200 million years ago, we had got some new change. We got some other change of hemoglobin. And actually, as you can see, up in the upper part, we have, I think, 5 or 6 different hemoglobin molecules. And the reason for that is that in the embryon inside the womb of the mother, the embryon will need to get blood, oxygen transported through over the placenta. So the embryon will need some kind of hemoglobin with slightly different properties to make this possible, so that oxygen will be transcended over the placenta. And this is a kind of scaffolding, if you like, of the mammalian way of life. And that's what genes are doing. Genes are scaffolding systems. And I will just take this one example because many of you don't know a thing about genes, I suppose. And there are all kinds of false thoughts about what genes are. Actually, I think I'll read this for you. We have here a layer, a syrup layer, I call it. The formation of a new syrup layer is indicated in dark. Cells in the newly formed layer grow and divide unless growth is inhibited by a signal molecule, syrupine, which is produced in the underlying layer in the light cells. Under the normal case, which we are shown in the middle, syrupine production is catalyzed by the enzyme syrupine synthetase, and the gene specifying syrupine synthetase is called SYR. Syrupine will slowly diffuse into the upper syrup layer and block any further growth, and then that's it. That's the size this layer should have. Then comes a mutation. A mutation in the SYRs caused a slightly decreased syrupine synthetase activity, leading to a decreased production rate for syrupine. As a consequence, syrupine concentration in the newly formed tissue only reaches the inhibitory level at a later time, allowing for extended growth of this tissue. So you get a much more extended growth of the... Imagine this is kind of your brain. Of course, that would cause a lot of troubles. Now, what does it tell us this? What does it tell us? It tells us that to modify genes is to change the way that different processes are tuned to each other. That's what genes are for. They are devices for sort of scaffolding ways in which enzyme processes in our body are tuned to each other. So what the genes really do specifies is the efficiency of semiotic modulators. And I mean, genes do nothing. It's not just something I say. Genes do nothing. They await being done. Enzymes have to come in and open them up and reading them and so on. It takes an awful lot of enzymes to do that. So the causal efficacy of genes presupposes that some living being is capable of interpreting them. So the cell must interpret the genes. That's the right way to understand genes. And genes, like word, cannot do anything. We don't believe in spells. I mean, if Alibaba says, open sesame, well, we don't expect that the rock will fall from the cave. No, that's not going to happen. Spells don't have this effect. But maybe, of course, God have listened to him, and so he said, well, better move that rock. So that's understandable. This might be a reason. So just as inert, intrinsically meaningless words serve to support human activity and communication, so do inert, intrinsically meaningless genes support cellular activity and communication. And bodies are like cities. Each of our estimated 100,000 billions of cells are ultimately autonomous units. The whole way of organization tells them to live and support their own life. And still they don't do that. For some strange reason, I think this is one of the greatest mysteries. That's what caused me to study biochemistry in the first place 40 years ago, or 50 years ago, rather. That how can we, when we are born, for 80, 90 years, all those 500,000 of molecules or cells do work together, and they never stop doing it. Until and most of them die away in just a very short span of time, a few weeks and so on. And the way this is done, of course, is by science systems. There are semiotic controls that manage to coordinate, to get all this whole system scaffolded. So, like traffic in the town, in the city, this is what semiotics is about. So, I should say life is strongly semiogenic. Organisms have a surprising capacity to take advantage of any regularities they might come upon. Regularities in the environment or in the body processes are easily appropriated by an organism as signposts directing its future behavior. And my favorite example is about the corn seedlings. Imagine corn seedlings being attacked by caterpillars. and then the corn plants emit a volatile. They respond by emitting a volatile. It's probably the spit of the caterpillar that releases this. So they releases a volatile component, a terpene, into the air, which blows away, and eventually it will land on the antenna of a wasp. And if this wasp is a skilled wasp, meaning it has tried this before, it will know that it should fly upstream against the wind, and this will bring it to the caterpillar. And then it will lay its eggs, the wasp eggs, in the caterpillar, and those eggs will hatch, and the wasp larva will start eating the caterpillar up from inside out. The last thing they eat is the nervous system. So that the corn seedlings have freed themselves from this attack. And this kind of cooperation, of course, presupposes nothing conscious. It's all just things which have been built up by nature to scaffold a certain way of living. And these kind of scaffoldings, I think, is what nature is about and what biology should be studying. And of course, it's very hard to study these things, but it's very important. We now know that plants very often, most often actually, are connected across bigger area through bridges made up of fungi that sort of make it able for one plant to communicate with the whole field of plants, if you like. In some call it a wood wide web. Yeah. Or consider this case of semiotic mutualism. Here, this is a crocodile having a bird inside. It won't eat the bird. Bird frees it from parasites, this Dickops. It's even so that the Dickops bird puts its own eggs in the neighborhood of the crocodile eggs, because the crocodile accepts it, because actually the Dickops bird warns it if there come predators. So the crocodile will need to go into the water, then the Dickops will take care of the eggs in the meantime. So what we can say that nature is full of those ecosemiotic interaction structures, which is actually scaffolding the ecological balances, and that's what it is all about. So if S is a measure of the tightness of the semiotic controls scaffolding a system, and E is a measure of the energy flow through the system, then S divided by E will be a measure for the ecological health of the system. That is, we should take care always to work semiotic controls into how we manage nature. The semiotic technologies are technologies that are instrument for increased semiotic control. Examples are modern data techniques, computers, smartphones, and biotechniques. And G technology is no more unecological than other host of other biological technologies. On the contrary, they are perfect examples of semiotic techniques, and there won't be much chance of saving the Earth without them. I agree. You do? Yeah. So what I would say, just to calm you down, don't blame the technology. Blame the political economy that leads to misuse. So that's the end of it.